Most automations wait for something like a form submit or an API call. But a lot of modern apps don't work that way. They stay connected and stream live messages, chat joins, live scores, price ticks, game updates. Today we're going to build a flow together using the WebSocket Event Trigger. That's a node that listens to that live stream and starts your workflow only when the right message shows up. And if the message looks like gibberish, don't worry, we'll decode it with a code node and the built-in AI assistant. No manual scripting required. Today we'll use a live score website as our example. What we're going to do is connect to a live match WebSocket, get the score in real time, and trigger our workflow with the score data we receive. Alright, first, the simple idea. Think of a webhook as someone knocking once on your door. A WebSocket is more like leaving the door open. Messages just keep walking in. This trigger is basically the doorman. It watches the stream, and when a message matches your rule, for example, the score just updated, it runs the rest of your workflow. Okay, so to start, let's look for a match that's already in progress. We're navigating to the tennis section, since those matches update the score fast enough, which makes it way easier to debug and build our WebSocket event trigger. Alright, let's take this one for example. Copy the tab URL and paste it into our node so we can load the page and grab the WebSocket URL. Quick side note, you can also get the WebSocket URL directly from DevTools. Open network, filter sockets only. But then you'd have to reverse engineer the on-connect handshake payload yourself. Our node already handles that for you, so let's skip the hard way and do it the fast way. This example doesn't need authentication to connect to the WebSocket stream, but in other cases, it might. So make sure you select a browser that's already logged in on the website you want events from. In this case, we can select any browser. We paste the tab URL, and now we click Navigate to URL. That loads the page, catches the WebSocket URL, and also catches the handshake and ping events that keep the connection alive. We recommend waiting a few seconds before selecting the link, so we catch everything needed for the connection handshake, subscribe to the stream, and keep the connection alive without leaving a browser instance running. After we select the WebSocket URL, notice how Use Browser switches off and the tab URL disappears. That means the browser and tab URL were only needed to grab the data for the connection, and you can see that right here in OnConnect. Now, in some cases, you may hit issues connecting with the browser off. That usually means the site needs a browser fingerprint to subscribe to the stream. Notice how the OnConnect section disappears. This means the handshake is already handled by the browser. Keeping the browser enabled and running for the whole session should fix it. Just keep in mind you'll also pay for browser usage. Let's switch the browser back to off to avoid that. Great. Now since we've got everything set up, let's connect and listen by clicking Start Listening. Okay, we're connected to the stream. Now up here in the top left, there's this bubble. That's the event log. If we click it, we should see streaming events live. And right here, we've got a filter, so we can cut the noise while we're debugging. Keep in mind, this filter does not control what triggers the flow. We'll get to that in a second. Direction is usually incoming, meaning messages coming to the page. Body contains is the magic filter. For example, only run when the message includes something unique from a score update. While we're here, from the Live Events panel, copy a real message body and spot which rows match your rules. Those get highlighted. Don't overthink control characters, just match the readable part. This live log is your debugger. You'll see messages as they arrive, filter by keyword, rules are OR. If any rule matches, it triggers. Leave them empty only if you really want every message to start a run. Pause, and the same kind of event won't run. Resume, and it runs again. When a message matches, the flow starts from this trigger node. Downstream steps get outputs you can wire. You'll get body. That's the message payload, and this is what we'll decode next. Direction tells you if it's in or out. And connection gives you the info so we can reuse the same socket later with send or close nodes. One more setting to notice here is queue. When queue is on, matching events run one at a time. If a score update comes in while a run is still going, it waits until that run finishes, then the next one starts. That's the safer default, especially when your flow writes somewhere, sends a notification, or shouldn't overlap itself. When queue is off, each matching event starts a run right away, even if a previous run is still in progress, so you can get overlapping runs. That's useful when events are independent and you want them handled as fast as they arrive. Just keep an eye on how many runs you're spinning up. For this live score example, we'll leave queue on so we process updates one by one. Okay, here's something beginners run into a lot. Not every WebSocket message is plain English or clean JSON. That's completely normal. You might see control characters plus a path, binary or base 64 blobs, or gibberish with readable words inside. Often that's gzip or pack data. The live log shows the raw wire message, what actually arrived. Copy gives you a JSON-safe string that's easier to read, and the trigger's body output is what your flow receives, usually the raw string. Body contains filters work on that raw readable text. Great for paths and score fields, but to turn a messy body into something organized, like JSON fields, here's the flow we're building. WebSocket Event Trigger into a code node, into a console log, or whatever comes next. Wire the trigger's body output into the code node. Rename the input to something clear, like body or raw message. So the code node has a real sample. Now open the code node and click the AI Assist button, the little robot icon. The assistant sees your wired sample data. It generates JavaScript that runs inside the code node. No imports, no fetch. You don't have to write JavaScript from scratch. Just describe what you want in plain English. The AI sees your real sample from the last run and drafts the decoder. You apply, test, and tweak. Maybe say also extract the match height until the output looks right. What the code node returns becomes your clean data for the rest of the flow. API calls, filters, notifications, whatever you need. Some sites use the same pattern. The socket sends a text-looking frame. Inside that frame, there's a gzip block. We let the log help us see inside. Then we use code plus AI to pull out the fields we care about. You don't need to reverse engineer every byte. Focus on listening is only half the story. When you need to reply on the same live connection, like send a chat message, join a room, or ping the server, add a WebSocket Send node. Wire the trigger's connection output into it. The Send node reuses that open socket, so we're not reconnecting from scratch. Write a small send call in JavaScript, same style as the code node, to push your message out. Typical flow looks like this: WebSocket Event Trigger, then code to decode, then WebSocket Send to reply. There's also WebSocket Close when you want to hang up cleanly. We'll cover Send in a follow-up. Today was catch, filter, and decode. Alright, quick recap of what we built together. We picked a live tennis match, opened the page, caught the socket and handshake, then started listening. We used the live log to watch score events, then filtered with body contained so only the right messages start the flow. Queue on means one run at a time. Turn it off if you want matching events to run in parallel. When bodies are encoded or messy, wire body into a code node and use AI Assist to build a decoder. Pause while debugging, stop when you're done. Need to talk back? Wire connection to WebSocket Send. You're not refreshing the site every second. You're listening to the same live wire the page uses, then turning it into data your workflow can actually use. I hope this was helpful. If you have questions, drop them in the comments. Thanks for watching, and I'll see you in the next one. WebSocket Send in detail.